Okay, investigating the change of base identity. What exactly does that mean? It means we're going to change something like this, which has a base of 5 to a base of 10, the common logarithm base of 10. So here we're looking at log 25 base 5, so we do the drop swing bump, 25 equals 5 to the v, so v must be 2. So log 25 base 5 equals 2. If we evaluate on our calculator log of 25 divided by log of 5, and even ln 25 divided by ln 5, we find that our answers are 2. Notice the similarity between this, well, thick pen, and what we have over here. Okay, we have log 25 base 5, but that actually equals log 25 divided by log of the base. So we can actually interchange these two expressions. They are equal. And in fact, if we had log 25 base 7, we could write it as log 25 over log 7. The base goes on the bottom of the denominator here. Okay, again, if we look at log of 243 base 3, we know that we can drop swing bump and get 243 is 3 to the v. And 243 is 3 to the 5, so v is 5, so our expression here is equal to 5. But if we do log 243, which is really base 10, because it's not written, divided by log of 3, which is the base, here we also get a value of 5. Okay, so, and it works with natural logs too. If instead of using base 10, we can use base e. Okay. In fact, you could change this to any base you like. In other words, if I rewrite this over here as log 243 and use a base of 7, I can, and let's look at this 3 here. We have to take log, the denominator of log 3, but also use base 7. You'll find that this is equivalent to this here. Our calculators, unfortunately, we can't enter this in, but we can enter in this as base 10. That's what it normally does when we log it, and we can also use log base e, which is really the ln. This is really, you can enter this into your calculator as ln of 243 over ln of 3, and that is automatically log with the base e on our calculator. That's the same calculation, and you'll get the answer to be 5. So the answer of this, no matter, as long as I've got log of 243 over log of 3, I can make the bases whatever number I want, as long as they're the same. The value of this is still 5. It's still the same value as this, or the same value as this. In the first page of this lesson, we learned that log 8 base 2 is 3. Write log 8 base 2 in a form which can be evaluated using a calculator and verify the answer. So here, what it's suggesting is to write this as log 8 divided by log 2. Now in your calculator, you can actually do this. Because before we didn't have a way to enter this in our calculator, now we do. We take log of 8 divided by log of 2, press enter, and we get our answer of 3. So in part D here, we take, if we want to evaluate log 64 base 2, we can punch into our calculator log 64 divided by log 2, we get our answer. Now here's an equation, basically the change of base identity. In other words, if you've got log c base b, you can write this as log c divided by log b, and you can make the base any number you want. Okay. Now with restrictions on what the base number normally is. I believe it cannot be 1, and it has to be greater than 0. A has to be greater than 0, and a cannot be equal to 1. I can double check that at the start of the log section, if I remember rightly. Okay, so we've seen that the above identity is true for converting logarithms to base 10 or base e. In fact, it holds true for converting logs to any base. So we can write this, for example, as log 1024 over log 4. In our calculator it equals 5, but we could make it as, instead of a base 10, which is unspoken here, base 2. And when you think about that, what is this? Well, the top line is really log 1024 divided by log 2, which is this, divided by log 4 divided by log 2, so this. Now we can punch this into the calculator, we get 10. We punch this into the calculator, we get 2. So 10 divided by 2 is 5. Excuse me. So, example 8, evaluate the following to the nearest hundredth by changing the base. We can write this as log 2 to 1 over log 5. Enter a calculator, we get the following result. The same with this. It's really log of 1,000th divided by log of 2. On our calculator, we get this. Log of a fraction is, if it's less than 1, will always give us a negative number. Here we have log of 512 divided by log 7. We can do that in our calculator and then multiply it by 3. Or we can go 3 times log 512, get an answer, and then divide it by log 7. Okay, let's do examples. Convert the following logs to the base that's indicated, to base 3. Well, we just put the 16 on top and the 6 below, and we can make any base we want, base 3 in this case. Okay. Log 300 to base 5. Well, this is really unspoken. It's a base 10, remember, so log of 300 over log of 10, and just make the base, both bases 5. Find the exact value of the following. Fair enough. So what would we do here? I guess we're using probably change of base. It says it's base 7 right now, but really our calculator deals with base 10 or base e, which is the ln. Well, let's convert it to base 10. This is really negative log of 1 over 343 divided by log of the 7. And if we punch this now into our calculator, we'll get a value of 3. This part here, the log of 1 over 343 is going to be negative, but this negative makes the whole thing positive again. Here we have 6 to the exponent. The exponent is a log. So let's evaluate the log, or rewrite it with base 10. It's going to be log 216 divided by log 6. The base is unspoken, that means it's 10. And when we do this calculation, this value is 3. So 6 to the 3, we get 216. Over here we can write this as log of square root of 1 over 1024 divided by log of 2, because that's the base. And you can just punch this directly into a calculator, you'll get negative 5. Okay, similarly over here we have log of 49 to the negative 5 divided by log 7, because that's the base. Punching this into our calculator directly, and remember if you're raising it you might want to include this in brackets, we'll get an answer of negative 10. Okay, a lot covered there, but again, try and do most of the problems, if not all, unless it gets kind of monotonous and you know how to do them. Skip a few of the letters in each problem set, and we'll see you in class.